Alright, this is video 2 for the strategic design unit. In this one, we're just solely going to talk about cost-benefit analyses. A cost-benefit analysis is a tool you can use to help you make decisions. For example, let's say we have 3 ideas for the drivetrain. Well, which drivetrain do we choose? It should be a choice based off of logic, that's engineering, but, there can be more than one logical answer. So what we can do is we can create a cost-benefit analysis of each drivetrain. And then we can use that cost-benefit analysis to help us choose which drivetrain is the one we should pursue. So the way I have this broken up is in terms of tasks and builds. So a task is something that your robot needs to do. So to start off with, you want to make a list of everything your robot needs to do. It needs to move, it needs to pick up objects. I mean, you can make a very, very long list, but I would say at least 3 items. So you've made 3 tasks for your robot to do. Each of those tasks, you want to give them a rank from 1 to 100, where 100 means that the task must be done, and a 1 is for a task that's not really important. So moving, I would rate that at maybe 90, 95. I mean, it's something that you probably should do. You wouldn't have to move. At least for last year's competition, you didn't have to move, and there were some robots that just stayed stationary and they just threw items in the net. But for this one, I would say for this year's contest, you probably should move, so it should be a little higher. The next thing is the cost. So going through your list of, let's say we had 3 tasks, so going through your list of 3 tasks, give each task a second rank. Again, from 1 to 100, we want to keep everything the same. Now this time 100 means it's a task that is hardest to do. And a rank of 1 is a task that's easiest to do. So now that each of our 3 tasks has 2 numbers assigned to it, one number being the benefit, another one being the cost, we want to find the ratio of benefit to cost. And once you get this fraction, reduce it, turn it into a decimal. I'd say turn it into a decimal. That's the easiest thing to do. We can use this ratio to make decisions. So let's say we have something that is 100. We must do it. It has a benefit of 100, like moving. And, let's say it's the easiest drivetrain to build. It's 1. Its benefit to cost ratio would be 100. So if something has a cost-benefit analysis of 100, that's something that you really, really should do. On the other hand, let's say something's not important. Attaching a flamethrower to your robot. And it's really hard to do that. So the cost is 100. Well, that's 1 divided by 100. That's 0.0, let's see if I can math. Yeah, 0.01. So that's the smallest ratio. That's something you should not go after because the cost-benefit analysis just doesn't work out. So I'd like to see some cost-benefit analyses for various tasks that your robot needs to do. The second cost-benefit analysis I want you to perform is one on the builds. So make a list of everything you need to build. You need to build a drivetrain. You need to build a lifting mechanism. You need to build an object manipulator. You might have 4 designs just for the lift. Well, which lifting mechanism should you go for? Well, we can use a cost-benefit analysis to help us make that decision. So, for the benefit side, give each thing you need to build a rank between 1 and 100. So this time, a rank of 100 means that you must build it. I'll just be up front. Chassis needs to have a 100. You must build a chassis because a chassis holds every single component of the robot. So a rank of 1 then is something that's not that important to build. You know, maybe you don't have to build it. Cost, okay, give each build design a second rank from 1 to 100. This time, 100 represents something that is very hard to build. So maybe some designs are harder to build than other designs. A rank of 1 then is a design that's easy to build. Once again, find the ratio of your benefit to cost. So if you had 4 designs for, let's say, the grabber, you can make a cost-benefit analysis for each of those designs, and then you can use that ratio to decide which grabber you should build. And again, since you're turning this into a decimal, the higher the number, 100 is the highest, 0.01 is the lowest. You can use that to make an informed decision on which design you should try to build. Now, there is a danger with these. One of the most common errors for this type of assessment is to underestimate the level of difficulty for a task or a build. So be conservative in your estimates. All right, that concludes video 2.